Hi, we'll be practicing graphing quadratics today. In the standard form, remember A will tell us if the parabola is opening up, smiling, or frowning. If it is opening up, the very bottom point is known as the minimum, the top point is known as the maximum. In every parabola, there is a line of symmetry. That's the fold line, which will have the left and the right be on top of each other when we graph. Using this simple equation, the first thing we're going to do is the line of symmetry. Using the opposite of b divided by 2a, I plug in my numbers, the opposite of b, -6, divided by 2 times 1. I get a line of symmetry of -3. I place a dashed line on my graph at x equals -3. Using that part, our answer, we plug it back into the original equation, solve, and I end up with y equals -16. My vertex is the point -3, -16. This comes from the line of symmetry. Asking myself, will I have a minimum or a max? Is it smiling or frowning? Using this purple dot, I put it on our graph. I know I don't have 16 rows, so we're going to have to pretend. Finally, the third step is just simply solving all that stuff we've been practicing. I need two numbers that add to 6, multiply to -7, solve, and I get roots or x-intercepts of -7 and 1. I place those with the two green dots. Notice they are equal distance from the line of symmetry, graphing my parabola there. Another example, again, the first step we're going to do is find the line of symmetry, the mirror point. Opposite of b divided by 2a, I got a line of symmetry of 2. I graphed using a dashed line where x equals 2. Using the line of symmetry, we plug it into the original equation, solve, I have a y value of -9. Line of symmetry, the solution is my vertex. I used a blue dot, it is a minimum at the point 2, -9. Solving for my roots, I'm looking for two numbers that add to -4, multiply to -5, solve. Those are my roots. Again, noticing their equal distance from the axis of symmetry. Another example, find the line of symmetry, opposite of b divided by 2a, and I got 3. That's the mirror line. Using that same equation, I will substitute 3, the line of symmetry, back into the equation to find my vertex. I end up with a vertex of the point 3, 0. Will this be a minimum or a max? I put a blue dot where the vertex is. It will be a minimum because my a is positive. I will solve, finding the roots. I need two numbers that add to -6 but multiply to +9. And I get -3 and -3, and I solve. Ooh, those numbers look familiar to me. The roots and the vertex are both negative or +3. So I put a green dot for my roots. Okay, so I don't have a parabola yet that I can sketch. Remember we talked about a while ago that the C in a standard form graph is the y-intercept. So I put a dot at the point 0, 9, the y-intercept. Because this is the line of symmetry, the y-intercept is 3 units to the left of the line. To find a second point in the parabola, I will go 3 units to the right. Now I have 3 points I can graph to create my parabola. Pause this video and try this one for yourself. Find the line of symmetry, the vertex, the roots, and just sketch a graph. I am hoping that you were able to calculate a line of symmetry of 1. I graphed a dashed line where x equaled 1. Using the line of symmetry of 1, I plugged it back into the original equation, and I got -16. So my vertex is the ordered pair 1, -16. Again, I had to pretend on my graph. Then I found my roots. When I solved, I ended up with x equals 5 and x equals -3. There again, equal distance from the line of symmetry. Try another one by yourself. Pause the video, find the line of symmetry, the vertex, the roots, and sketch a graph. Hoping that you got -1 is your line of symmetry. Sketch. Plugging -1 back into the equation, I hope you have a vertex of -1, +2. Oh dear, when I go to solve, we used to call these prime, but they cannot be prime. We're smarter than that. In the equation, I noticed my C was +3, so I put a dot in green at the intercept 3, that is 1 to the right, so I know I'll have another one 1 to the left. That was very fast, I realize. This video is long, but very thorough, using a lot of the same vocabulary I use in the classroom. It is a great video to watch. Here's a real quick one. He shows you how to use a T-chart. You can always use T-charts when solving and graphing quadratics. Below I have included a form for you. This will be your homework assignment. In each one, I'm going to give you an equation, and from that equation I want the line or axis of symmetry, I want the vertex, and I want the roots. Please read the directions on how to input your answers accurately.